Small Satellite Launch Vehicle, SSLV. The Small Satellite Launch Vehicle, SSLV, is a small-lift launch vehicle developed by the Indian Space Research Organisation, ISRO, to deliver 500 kilograms, 1,100 pounds, payload to low Earth orbit, LEO, 500 kilometers, 310 miles, or 300 kilograms, 660 pounds, payload to Sun-synchronous orbit, SSO, 500 kilometers, 310 miles. The rocket supports multi-orbital drop-offs capability for small satellites. The maiden flight SSLV-D1 was conducted from First Launch Pad, FLP, Satish Dhawan Space Center, SDSC, on August 7, 2022, however, the payload failed to reach the intended orbit. The second flight SSLV-D2 was successful in delivering payload into orbit on February 10, 2023. SSLV is made keeping low cost, low turnaround time in mind with launch-on-demand flexibility under minimal infrastructure requirements. It is capable of carrying multiple satellites. Once SSLV is operational, New Space India Limited, NSAL, and a group of Indian companies will manage the mass production and launch activities. In 2015, a National Institute of Advanced Studies, NIS, report by Rajaram Nagappa proposed development path of a small satellite launch vehicle 1 to launch strategic payloads. In National Space Science Symposium, NSSS, 2016, then Director of Liquid Propulsion Systems Center, LPSC, Shrivara Panikkar Somanath also acknowledged a need for identifying a cost-effective launch vehicle configuration with 500 kilograms, 1,100 pounds, payload capacity to LEO, and by November 2017, development of such launch vehicle was underway. By December 2018, the Vikram Sarabhai Space Center, VSSC, completed the design for the vehicle. The aerodynamic characterization research was conducted at the National Aerospace Laboratories, NAL, 1.2 meter, 3.9 foot, trisonic wind tunnel facility. In December 2020, all booster segments for SSLV First Stage, SS1, Static Test, ST01, were received and assembly was done in Second Vehicle Assembly Building, SVAB. The first static fire test, ST01, of the SS1 First Stage booster conducted on March 18, 2021 was unsuccessful. About 60 seconds into the test, oscillations were observed and after 95 seconds, the nozzle of SS1 stage disintegrated. The nominal duration of test was 110 seconds. To qualify for flight, SSLV's solid first stage SS1 has to perform 2 consecutive nominal static fire tests. The SSLV Payload Fairing, SPLF, functional qualification test was completed in August 2021. The second static fire test of SSLV First Stage SS1 was conducted on March 14, 2022 at SDSC Shar and met the required test objectives. ISRO carried out a successful static test of an improved version of the third stage of the SSLV on December 30, 2025 at the Solid Motor Static Test Facility of SDSC. It validated an improved version of the SS3 stage with a carbon epoxy motor case built by VSSC, which has significantly reduced the mass of the stage, thereby improving the payload performance of SSLV by 90 kilograms, 198.4 pounds. The stage also features an improved design for the igniter and nozzle system. It will be deployed on the next flight mission of the SSLV onwards. The first developmental flight of the SSLV occurred on August 7, 2022. The flight mission was named SSLV-D1. The SSLV-D1 flight failed to achieve its mission objectives. The rocket had a 3-stage configuration with a fourth velocity trimming module, VTM. In its D1 configuration, the rocket was 34 meters, 112 feet, tall with a diameter of 2 meters, 6 feet 7 inches, and a lift-off mass of 120 metric tons, 120 long tons, 130 short tons. The rocket carried EOS-02, an Earth observation satellite that weighed 135 kilograms, 297.6 pounds, and AZADI-SAT, a CubeSat payload that weighed 8 kilograms, 17.6 pounds, developed by Indian students to promote inclusivity in science, technology, engineering, and mathematics, STEM, education. The SSLV-D1 was supposed to place the two satellite payloads in a circular orbit of altitude 356.2 kilometers, 221.3 miles, with 37.2 degrees inclination. The official explanation by the ISRO for the mission failure was software malfunction. According to the ISRO, the mission software detected an accelerometer anomaly during the second stage separation. This caused the rocket navigation to switch from a closed-loop guidance to an open-loop guidance. Even though this switch in guidance mode was part of the redundancy built into the rocket's navigation, it could not salvage the mission. During the open-loop guidance mode, the final VTM stage only managed to fire for 0.1 second instead of the intended 20 seconds. This led to the two satellites as well as the VTM stage of the rocket being injected into an unstable elliptical transatmospheric orbit of 360.56 to 75.66 kilometers, 224 to 47 miles, with an inclination of 36.56 degrees. The SSLV-D1's final VTM stage had 16 hydrazine, MMH plus MON3, fuel thrusters. 8 of those were to provide altitude control and the remaining 8 for controlling the orbital velocity. The VTM stage also provided pitch, yaw, and roll control during the orbital insertion maneuvers. The three main stages of the SSLV-D1 functioned normally. But that was not enough to impart adequate impulse for the two satellite payloads to achieve stable orbits. For the injection of the two satellite payloads into their intended stable orbits, the VTM stage had to fire for at least 20 seconds, to impart enough additional orbital velocity and altitude corrections. Instead, the VTM kicked in at 653.5 seconds and shut itself down at 653.6 seconds, post-liftoff. Following the partial firing of the VTM stage, the EOS-02 was released at 738.5 seconds and AZADI-SAT at 788.4 seconds, post-liftoff. These failures transpired, resulting in the satellites entering an unstable orbit and subsequently destroyed upon re-entry. On February 10, 2023, SSLV completed its second developmental mission, putting 3 satellites into their planned orbits. The 3-stage rocket successfully launched EOS-07 into a circular orbit around 13 minutes after liftoff. Also, JANUS-1 and AZADI-SAT-2 satellites into their orbits about 1.6 minutes later. The purpose of SSLV-D2 is to launch the 3 satellites into a 450-kilometer, 280-mile, circular orbit and showcase the in-flight performance of the SSLV vehicle systems. A total of 175.2 kilograms, 386.2 pounds, was carried by the SSLV-D2, 10.2 kilograms, 22.5 pounds, for JANUS-1, 8.7 kilograms, 19.2 pounds, for AZADI-SAT-2, and 156.3 kilograms, 344.6 pounds, for EOS-07. After analyzing the problems with SSLV-D1, ISRO chose the necessary remedial measures and put them into practice. The development team conducted a number of simulations and studies to make sure that SSLV-D2 mission would succeed. According to SSLV-D1 fault evaluation study, 6 onboard accelerometers detected vibrations that were longer in duration and more intense during the second stage of separation. In order to ensure that this problem doesn't occur again, the second stage detachment system in SSLV-D2 mission was modified to reduce vibrations. Furthermore, the system was redesigned to navigate utilizing NAV-IC, navigation with Indian constellation. Data and readings will now be monitored for a longer time before entering rescue mode. The separation mechanism, the equipment bay, and the onboard system for identifying malfunctioning sensors were further modified and 5 new pieces of hardware were installed. The electronics in SSLV-D2 worked successfully, as did the launch vehicle's new, affordable guidance and navigation system. The Earth observation satellite EOS-08 was launched by ISRO on August 16, 2024, using SSLV D3. At the Satish Dhawan Space Center, SDSC, the final development flight successfully took off from the first launch pad. After 17 minutes, the EOS-08 was injected into a 475-kilometer, 295-mile, circular orbit, following the instructed injection conditions without any deviations. The SSLV development process is now officially complete. The development team will continue to search for specific operational activities in the VTM stage before ISRO supplies the industry with SSLV technology for serial production. Any necessary fine-tuning will be finished prior to the technology transfer. With a 72-hour turnaround time, the ability to support several satellites, a small launch infrastructure requirement with a team of 6 people, and the possibility of launch on demand, SSLV is now a cost-effective solution. Repeatable flight performance of the SSLV vehicle systems has also been demonstrated by SSLV D3. The successful flight of SSLV D3 permits the Indian private sector and New Space India Limited to use the rocket for operational flights. The SSLV project was completed after more than 7 years of construction. 6 companies are now in the process of acquiring the SSLV technology, while at least 10 companies and consortia have expressed interest in manufacturing. The integration and launch time of SSLV rocket is less than 24 hours. The SSLV program has been planned from the beginning a rocket to be privatized by ISRO. As of February 2025, a bidding process is underway. Prominent Indian companies such as Adani Defence, Bharat Dynamics Limited, and Hindustan Aeronautics Limited, HAL, have expressed interest in bidding for the vehicle. In June 2025, Hindustan Aeronautics Limited was awarded the full contract to manufacture, market, and launch the SSLV rocket, following a transfer of technology, TOT agreement with ISRO. HAL was selected from a list of 9 bidders and were the highest techno-commercial bid, valued at 5.1 billion Indian rupees, $59 million. The TOT agreement is expected to take 2 years to finalize. ISRO is planning to award a contract to HAL in partnership with L&T for the supply of an initial batch of 5 SSLV rockets for ISRO launches. The SSLV was developed with the aim of launching small satellites commercially at drastically reduced price and higher launch rate compared to Polar Satellite Launch Vehicle, PSLV. The development cost of SSLV is 169.07 Indian rupees crore, equivalent to 190 Indian rupees crore or $22 million in 2023, and the manufacturing cost is expected to be 30 Indian rupees crore, $3.5 million to 35 Indian rupees crore, $4.1 million. According to analysts, this places it among the most affordable rockets in its class. The projected high launch rate relies on largely autonomous launch operation and on overall simple logistics. To compare, a PSLV launch involves 600 officials while SSLV launch operations would be managed by a small team of about 6 people. The launch readiness period of the SSLV is expected to be less than a week instead of months. The launch vehicle can be assembled both vertically like the existing PSLV and Geosynchronous Satellite Launch Vehicle, GSLV, and horizontally like the Retired Satellite Launch Vehicle, SLV, and Augmented Satellite Launch Vehicle, ASLV. The first 3 stages of the vehicle use hydroxyl-terminated polybutadiene, HTPB, based solid propellant, with a 4th terminal stage being a velocity trimming module, VTM, with 850 newtons, 11.24 pounds force, thrusters for reaction control and 850 newtons, 11.24 pounds force, axial thrusters for changing velocity. With these VTM can add delta V of up to 172 meters per second. The first stage, SS1, and third stage, SS3, of SSLV are newly developed while second stage, SS2, is derived from third stage, HPS3, of PSLV.